everyone. So in this video, we're going to go over parallelograms and other special quadrilaterals. I always get a lot of questions about how to remember the properties and how to prove that something is a parallelogram or a square or a rhombus or a rectangle. Every book has all the properties listed out word by word, and of course you could go through and memorize all of that, but what I'm going to give you are some special visual tools to help you remember those properties without actually memorizing them word for word. So my first thing that I always draw is this flowchart. You've probably seen it in some of your own classes, but at the very top we have quadrilaterals. All that is any four-sided shape. So nothing too special about that. It just has to have four sides. So that's at the top of our flowchart. Now, a really important subcategory of quadrilaterals are parallelograms. And those are the shapes that have both pairs of opposite sides parallel. So if you can just visualize that, it would be this shape, and by the definition, it's those sides parallel and those two sides parallel. Now under parallelograms, we kind of branch off here into rectangles on one side and rhombuses on the other. So a rectangle is a type of parallelogram that has four right angles. But its sides, all four sides don't have to be congruent. That's where a square comes in. And then a rhombus is a parallelogram that does not have four right angles, but it has all four sides congruent. And if you merge these two, a rectangle and a rhombus, that's when you get a square. So the square has all four sides congruent and all four angles are right angles. So here's rectangles, rhombus. Alright, and then kind of hanging out over here are the kites. They look just like a kite that you would see in the sky. Those two are congruent, and those two are congruent. But you can see that you don't have opposite sides that are parallel, so it is not a type of parallelogram. And some teachers just leave the kites completely separate by themselves over here, but some teachers and some books have them connected separately to a rhombus because you could think of a rhombus as a type of kite. And then completely on the other side, let's do this, trapezoids. They are not a type of parallelogram, but they do have four sides. So they're quadrilaterals. And you can picture what those look like. They're like that. The important thing is that the two bases are parallel to each other. So we have that. And then if you break it down into one special type, there are isosceles trapezoids. And that's when it would be very symmetric looking. You would have something like that, that. And so the bases are still parallel, and these legs of the trapezoid are congruent. So that causes it to be an isosceles trapezoid. I probably should also go back here to the kites and connect them to the quadrilateral bubble, because since they have four sides, they're of course a quadrilateral. Now how this flowchart can really help is in the always, sometimes, never questions. So for example, if they say a square is a rhombus, we can say always. If they ask, a rhombus is a square, we can say sometimes. And then if they try to do this, a rhombus is a trapezoid, we would say never. Now here's how the chart helps visually. A square is a rhombus, that first statement I wrote, that's looking up. That's looking from the bottom up. Oops. The bottom up in the chart. Bottom up is always. The second statement I wrote, there's the second one. The second statement I wrote, a rhombus is a square. That's looking downward in the chart, a rhombus being a square. Those are always sometimes answers. So whenever you're looking downward, you will be saying sometimes. And then the third statement, that a rhombus is a trapezoid, well, then we were trying to go sideways in the flowchart. That will be a never when you're trying to do that. The only time a sideways wouldn't be never is if they said a rectangle is a type of rhombus. Like this, a rectangle is a type of rhombus. Then you could say sometimes that's a special case, because if that rectangle happened to be a square, then it would also be a rhombus. But those things are connected like in a little circle with each other, so that's why it's an exception to the little sideways rule. But just think of the sideways like if they're asking, is a parallelogram a trapezoid? Never. Is a rectangle an isosceles trapezoid? Never. And if you use that rule, that in general can help you. Now, the other thing to get a good handle on is when they ask you for the most descriptive name of one of these shapes, and then they put symbols on the shape, and then just from the symbols you're supposed to say, oh, this is a parallelogram, or oh, this is a square. So this is where a lot of the properties come in of these shapes. So there's 5 different ways of knowing that a shape is a parallelogram. The most basic is if they mark parallel markings there and there. Then you could immediately say that's a parallelogram. Or if they mark congruent markings on the opposite sides, that means that both pairs of opposite sides are congruent, that immediately would be a parallelogram. Or if they mark one pair of sides parallel, but then they also mark that same pair of sides congruent, then the most descriptive name is parallelogram. Again, if they mark opposite angles congruent, like those two and those two, again, it's a parallelogram. And then the final thing is if the diagonals bisect each other, you'd see a marking like that, and then like that. So again, it's a parallelogram. So if you see any of these 5 markings on a picture, the most descriptive name would be a parallelogram. Your goal with most descriptive name is to name the shape as far down in the flowchart that you can go, and have it still be true. So for example, if we look back at the flowchart, if all they said was that opposite sides were parallel, both pairs of opposite sides, the farthest down in my chart that I can go is parallelogram. because if I go all the way down to square, it might not necessarily be a square if just both pairs of opposite sides are parallel. But we know for sure that it would be a parallelogram. So the lowest we can go in the flowchart without it being sometimes false, that's the most descriptive name. And these markings that I just drew on all of these parallelograms, the most descriptive that you could call that shape would be a parallelogram. It wouldn't force it to be anything else. Now, where it gets a little confusing is when you're trying to name what it is just by looking at the diagonals. And they do this a lot. So if they draw in the diagonals on a certain picture, and they show you that they're both bisected, but with different markings, then the most descriptive you can say is that it's a parallelogram. Because in this situation, the diagonals are bisecting each other. Now think about if I drew kind of that same thing. I have the diagonals, but what if I made them all the same marking? Well, now the diagonals are bisecting each other still, but by having all the same marking, it means that those diagonals would be congruent. And when we have that, the most descriptive name would be that it's a rectangle. Alright, now, if I draw the two diagonals, and let's say I have one of them is being bisected, and then I put a 90-degree angle at the center, that is actually a property of kites. So we could say, the most descriptive thing that we could say is that it's a kite. And then, kind of building off of that, if I draw the diagonals, and I make this one congruent, and then I draw a 90, and then how about if I also bisect this one? Well, if both diagonals are bisected and there's a 90, then that immediately makes it a rhombus. And that would be the most descriptive name for that one. And I just thought of a way to show a square. So let's add in a number 5 for this. If they showed, they can draw any shape. It can be looking like a rectangle. It's the markings that matter. So let's say they showed the diagonals and they put all 4 marks the same and they put a 90 at the center. That would tell us that the diagonals are congruent, meaning that it's a rectangle, and the 90 at the center tells us that it's a rhombus. So those two things together, we could go all the way down in the flowchart as low as possible to a square. So that would be what we would call that for most descriptive name. So for most descriptive name, just remember you're trying to go as low as you can in the flowchart without it turning into something that's false. And these are the markings that you can look for with the diagonals. And then there's a few other ways that they can show pictures and then you can know what it is. So like I've seen this before. They draw 90 and 90 right there, which causes this to be parallel to that. That's what that would mean. And then they put different numbers here, like 8 and 10, so then you know it's not a parallelogram. But just having that one pair of parallel sides, then we know that it's a trapezoid. And then the other thing I've seen them do is to mark like these two congruent, and then put a parallel marking on those two. And then we would know that it's an isosceles trapezoid. And one clever way they can show rectangle without just telling you that the angles are 90 is if all 4 angles are just marked congruent. That would force it to be a rectangle because then they would have to be 90. So there's lots of other little markings that they can put on pictures that would immediately tell you what the most descriptive name would be. I just tried to pick out the hardest examples, and my students always have trouble when it's shown with the diagonals on this page. So that's why I picked those to concentrate on. And the parallelograms are super important, so that's why I picked those.